what you see on the string there?
Yeah, it's an elephant on a string. That's really interesting.
Well, you probably have never seen a picture on a string before.
No, never.
So maybe I should explain what's going on. There's a 35mm projector over there, and I have a picture of an elephant in it. Now, the picture is actually coming along here, you know. It's right there in midair, but we can't see it. Didn't you know that light was invisible like that?
No, I didn't know that before.
Well, when you see a shaft of light coming through the room, what is it that you're really seeing if there's dust in the room?
You're seeing a beam of light.
No, you're seeing the little pieces of dust. It's only when the light hits it and reflects it from the dust that you actually see it.
Oh,
right?
I see, yeah.
So, you know, if you pop a eraser or something, you can see all the little dust, and then the beam of light. In fact, that's one of the problems with scientific experiments. They have to get smoke or something in the air to make the light visible. It's only when it bounces off of it. And that's how your television set works, too.
Oh, really?
Well, not quite. What happens in your television, there's a beam of electrons that goes across and creates part of a picture. Sort of like this. There's part of the picture right there.
Yeah, but you can't see all of the picture, only a small part.
Because that's only one little thin line of it.
Yeah.
Right. Now then, if you painted the picture there, and then painted the picture here, and then painted the picture there, and you did it fast enough, you'd see all three at once.
Yeah, that's because the string is going so fast, you can see the picture. It's like a surface. Yeah,
well, so is your television going back and forth so fast. 60 times a second, it's going, creating a whole new picture made up of little tiny lines like this. So this is how you can make a picture on a string, by getting a projector and now somehow putting something in the way of it. In place of my hand, it's going to be the string going up and down. And see if I can get it to go again, and you'll see a picture on a string.
That's neat.
Isn't that neat? I don't know if you've ever seen one of these before, but it's called a pin piano.
Oh.
And you see why? It makes sort of piano-like sounds using pins.
Oh.
And here's how you make one of these for your little friends. First of all, you got to get fairly tall, heavy kind of pins. Okay. Now, then you start putting them in the piece of wood. And how come they make different sounds? What's vibrating?
Well, the pins are.
Which is the high note and which is the low note?
Well, this is the low note, and that's the high note.
This is the low note, and that's the high note.
Right.
Why?
Well, more pin in this is sticking out.
Right, so it means more of it's vibrating, so it vibrates more slowly. And of course, this one at the top. How would you tune it? If it's too high, what do you do?
Well, if it's too high, you could pull it out a bit.
Pull it out just a little bit. If it's too low?
Push it in a bit.
Yeah. In fact, here's the important tool that you need, because when you get to the very short ones, you have to sometimes cut off the pins without a sort of sharp point and then drive them in, because otherwise you'll bend the pin. Now, it doesn't make too loud a sound here. We're going to make it louder. What will this do?
Well, that'll make the big pan vibrate and make a louder noise.
Yes, a louder noise. So try that.
Yeah, it's quite a bit louder.
Now notice what you're using to play it with. Pencil, another one of these big pins, stick it in the end, and cut the head off. Oh. And that becomes the pick. One of my favorite tunes for pin piano, because you only have the scale at this point, is this. Da-da, da-da, da-da.
Oh,
This takes the notes of the scale. Would you like to try? Play something?
Okay.
Doesn't it sound something like a music box?
Yeah, I think because the music box plucks their little...
Those little things that stick out, yeah. Any other instruments in the orchestra in which the solid is vibrating, like our pins are?
Well, the piano.
Yes.
The stringed instruments like violin and cellos.
Yes. Any others?
Cymbals and drums.
Yeah, and bells and chimes and all those work on the same idea as a pin piano. So if you're going to make one of these for a friend, just get nice big pins, drive them into a soft piece of wood, tune it by putting the pin further in or out, and you can have a nice pin piano. This is not the surface of a lifeless planet. You're looking at plants that produce no leaves, flowers, or seeds. They get their nourishment through thread-like structures that spread out into the tissues on which the plants grow. Be sure to take a close look at these fascinating plants before you throw away a moldy orange. I assume you've used one of the old-fashioned typewriters, Stacy, right?
Yes, I have.
When you push the key, a mechanical, linkage went on, a little thing went and hit the paper and so forth. And that worked reasonably well to get your ideas down on paper. But today we're going to sort of investigate a new frontier in putting things on paper by looking at a word processor.
Okay.
Okay? Now, what were some of the problems with the old-fashioned typewriters?
Well, if you made a mistake by hitting the wrong key, then you had to use some type of correction fluid, and it always showed up. But if you happened to notice a mistake after you pulled the paper out of the roll, well, there was no chance of you getting it lined up again.
Well, and there's some more modern typewriters that use electricity to help make the keys work and so forth. But with a word processor, like the one you're going to look at today, you don't do any typing until it's absolutely perfect, exactly the way you want it, and then it types it out very, very fast. So I have put a little saying, Jack and Jill went up the hill, and I've made all kinds of errors in it, so you're going to correct them and fix them all up using the word processor. Okay. But first you better know how to use the keyboard. So I assume you know what those little arrows are for.
Yes, they control the cursor.
Down, up,
left, and right.
Left and right. And on this particular word processor, F1 is an insert key when you want to insert something, and F2 is a delete key when you want to delete something. Okay, see what I've written?
Jack and Bill went up the hill to fetch a pail of water. Jack fell down and broke his crown, and Jill came tumbling after.
Okay, now this time, all you have to do, you don't erase in this case, all you do is just type right over any mistake.
Okay, so I just use the cursor control keys. So I'm changing this Bill to Jill.
Okay, and then?
And then I'm going to go over some more and change the pill to an H. Change the pill to hill, I mean. Oops, I don't need that. There.
Now, in this case, the computer had, first of all, sent some numbers into its memory, and it said, when you hit that key, it said, go to that number, erase it, and put this new number in.
Okay.
Now move down to the next group. And see what this one says?
It says, Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke this crown, and Jill came tumbling after.
And see the line, the cursor's on there where you have it right now. It says delete. So this time you're simply going to hit F2 to get rid of whatever it is you want to do.
Okay.
A real erase sort of feature.
Go down.
But the interesting thing about it, watch what happens when you hit F2 now.
Oh, it moves the line over.
Yeah, it moves the whole line over.
So I'll change this to
You're sending an electrical signal to the computer to erase that number. And, okay, now the next one.
Jack, blank, you need an and in there. Jack, Jill went up the need that.
Yeah, you need a thing in there too.
Yeah.
Okay. Now this time I've left out some things, so you're going to insert it by using that F1 key over there.
Okay.
Okay. Move it down. What's missing?
Jack, Jill went uphill. Well, you're missing an and at that. So.
Okay, so go ahead and put them in.
Okay. Oops.
Down one, back up. Okay, down one and I'll back up. There's faster ways, as I said, of moving the cursor, but for now you can do that. Okay, now insert F1.
Okay.
Okay, a space.
And Jack and Jill.
And by the way, you don't have to just insert 3 letters. You could keep going. You could add a whole 100 there if you wanted.
Okay. So I'll move it over and put in that.
F1.
Space. That.
F2. There you go.
That one's finished.
Go down to the next one now.
Okay.
Because what's wrong with that?
Jack fell down and broke his crown, and Jill came tumbling after. Jack and Jill went up the hill to fetch a pail of water. Well, the 2 lines are reversed.
Okay, this time we're going to do what is known as a block move. So put the cursor in any place in that first line.
Okay.
Okay, now Control D. P for paragraph. Oh, hit break.
Okay.
Control D. Okay, now P for paragraph. And the second paragraph. Now you want to move it. M.
Okay.
Okay, now move the cursor down to where you want it to go. And now Control R. Replace. And there it is. Okay, well, those are some of the things that you can do with a modern word processor. Now I think we ought to print it. So do Control U.
Control U.
P for print. And escape. Hit break. Okay. There it is. You know how a lawnmower works. A blade cuts off the grass just above the ground. Imagine those blades of grass are trees, and you want to design a machine to cut them off in the same way. Well, that's exactly what this machine does. Not only does it cut off trees near the ground, it chops them up into pieces. At the front is a bar that does the cutting. Side rollers with spikes and a blade that looks like a huge knife help guide the trees into the blades of the chipper. As the giant machine moves forward, it can cut down trees as thick as a foot in diameter, which are blown out the other end as chips a few inches square. This is a test run. When the machine is in actual operation, the chips can be collected and burned at the local sawmill, or eventually made into paper. The machine was invented by Dr. Peter Koch of the U.S. Forest Service to clear away the trees left behind after larger trees had been harvested for lumber. A giant machine that mows down the old trees and chops them to pieces to clear land for the planting of new trees. You have adding machine tape at home?
Yeah, it's my dad's.
Okay, well, Tanis, ask him if you can use some of it, or you can cut it out of a piece of paper. What you want to do is form it into a nice loop like that.
Okay.
Now, before we get started investigating a sort of strange geometry called topology, how many surfaces are on this loop?
2. One on the outside and one on the inside.
How many edges?
One here and one there.
Okay.
2.
And if you cut it in half, what'll happen?
You'll get 2 pieces of paper.
Careful of my fingers. Do you?
Yeah, 2 pieces of paper.
Okay, just as you expected. Here's the same sort of strip of paper, but this time, when you put the 2 ends together, give it a half twist.
Okay.
How many surfaces?
2.
How many edges?
2.
See that pencil?
Yeah.
Put it down here to mark the surface.
Okay.
Right there in the middle. Okay. Now I'll pull it and you draw along there. And whatever you do, don't take your pencil off of that surface. Don't lift it. That's it. There's the joint.
There is only one. It came back right to where I started.
So how many surfaces?
1.
Yes, only 1. And now, if I put a null mark here on one edge like that, and you keep track of the edge, how many edges will there be, do you suspect?
1.
Okay, hold it there. One edge. A strange sort of thing happens when you give it a half twist. You get 1 surface, 1 edge. Now what'll happen when you cut it in half like you did the other one?
I'm not too sure. I think maybe it'll give 2 pieces of paper like the last time.
Okay.
It only gave 1 piece of long paper. Just
great big
one
long
piece.
one. Yes. So what do you do to get great big long one?
Give a half
Half
twist.
twist. Same piece, this time a full twist when I put it together. How many surfaces?
1.
How many edges?
1.
What'll happen when you cut it?
I really don't know this time.
Okay, let's try it and see what happens.
It made 2 pieces of paper, but they're linked together
Yes. So how are you going to make this one?
with a full
A full twist. Yes, and these were invented by Mobius, who was a famous astronomer, and they call so that's why they're called Mobius, M-O-B-I-U-S. Weird, weird strips.
Yeah, really weird.
This beautiful picture of the Milky Way looks like it's been ruined by a big fat scratch. But the light from the stars is so faint, astronomers have to expose the film at the end of the telescope for a long time in order to take a picture. While the camera shutter was open, a tiny grain of dust from outer space entered the Earth's atmosphere. The friction of the air made it so hot it burned up. The camera recorded the fiery path of what you call a falling star. Jason, you know the air is invisible. How do you know when it's moving?
Well, things move like the leaves up in that tree.
Sure. Or flags and things like that.
Yeah.
I wondered, have you ever thought, why does the wind blow in the first place? What makes it move? How come the wind blows?
Oh, what does make the wind blow?
Well, come on in. I've got an aquarium. You know what an aquarium is?
Like with fish?
Yeah, I think I can show you with that.
Oh, okay. But I still don't understand how an aquarium is going to show me how the wind blows.
Well, I think you'll see in a minute. First of all, would you get a dish of ice cubes I have over there in the freezer and bring them up here?
All right. Is this the bowl?
Yeah, great.
Okay. Here.
Now, I had this lamp on heating up the aquarium because it's an aquarium without any water in it.
Oh, I thought there would be water.
You know, and it represents sort of a little section of the air. That could be 1,000 miles from one side of the aquarium to the other.
Oh.
I'll put this top on like this, and over on the other side, put some ice cubes. That represents a cool area of the Earth, and obviously this is the sun shining down, creating a hot area of the Earth.
Oh,
Now already there's a wind blowing down there.
there is?
Yeah, but remember when I said outside you can't see the wind blow because you can't see the air
Oh,
itself.
yeah, okay.
Has to be like a leaf shaking in the wind. Well, what we need is a smoke source. And here's kind of an unusual one. Here, take that. Well, I like you recognize that?
It's a soda straw.
But paper straw.
Oh, yes.
Remember
it
one of
is.
those old-fashioned kind? Mm-hmm. Okay, well, the fact that it's made of paper and covered with wax is the reason why I can use it as a good smoke source. First of all, I'll set it on fire.
Okay.
Now, as it burns, it forms a hollow ash. See the end there?
Yes.
Okay, and as it burns, there's wax on the inside of the straw. So the flame there vaporizes the wax. And if I pinch the other end to prevent oxygen from coming in, see, I got a nice stream of vaporized paraffin.
You can already see the wind blowing the
Yeah, see how the air in the
smoke
room is
around.
moving?
Yes.
Okay, now I watch what happens when I put it here in our little cross-section of air.
Well, oh. The smoke is kind of coating the bottom of the...
Yeah, see, first of all, it's going down over the ice cubes, right?
Yes.
Because the air is cooler over there. So it's
Oh.
heavier than an equal amount of warm air heated by the sun on the other side. So the cold air flows from the cold area to where?
To the warm area.
Heated by the sun. So anytime the Earth is heated unevenly, that could be at the equator and the poles, or over a field, or over water compared to land, the air will flow from the cool side to the warm side, and that's what makes the wind blow. Here's a kind of interesting figure. Have you ever seen a figure like that?
Yeah, it's egg-shaped.
Yes, egg-shaped, but that's not its geometric name. Its geometric name is an ellipse.
Eclipse?
Ellipse, E-L-L, ellipse. And it's an interesting figure because it's a circular figure with two foci.
Foci?
Yeah, it's a new word for you probably. You know what a focus is?
Oh, yeah.
Okay, this is plural, foci.
Oh, okay.
And I'll show you how to draw one before you leave, and all you need is a piece of string and a pen. Okay? First, let's draw a circular figure with one focus.
A circle.
Right, you can draw that in the center over there.
There.
Okay, now that is a circular figure with a center or one focus.
Right.
Okay, Can you think of a figure around the house that looks like this? You mentioned an egg, and that's not really elliptical. It's not really an ellipse, it's elliptical. Somewhat like an ellipse, because an egg is fatter on one side, isn't it?
Yeah.
And this is not. Any others?
No.
Football.
Oh, yeah.
See, now that's elliptical also because it's pointed at each end.
Right.
So they just say it's like an ellipse. Well, I collected a bunch of stuff from around the house over here, and I want you to take a look at them and see if you can find an ellipse.
The can.
The can. Anything else?
And no, the rest are just circles.
Wrong.
Wrong.
Wrong. Here's a plate. It's a circle, right?
Okay.
Okay, now I want you to tilt the plate and look at it very carefully. Here, put it down so you can see sort of over the top. Okay, now, it's no longer a circle?
It's an ellipse.
Yes, it's an ellipse.
Still, it's getting wider and
Yeah,
skinnier.
now it's practically a line, right? And then when you turn it around, it's an ellipse.
Now
it's a circle again.
Yeah.
So whenever
It's
you... Yeah, go
Yeah,
ahead.
it's only a circle when you're looking from this way or at this side.
Right.
The rest of the time, in the other angle, it's always...
It's always an ellipse.
Yeah.
Yeah, so when I said, could you find any ellipses over here, that's the plural, every one of those objects should have been called an ellipse.
Right.
And when artists draw, here, take the cup, for example.
Okay.
If you're going to draw the cup, you know how you do it? You'd make an ellipse here, and you'd put two straight lines down, right?
Right.
Because the circles supposedly at the top and bottom are really ellipses. Okay, turn it sideways, too. Still an ellipse.
Yeah.
Only when you look at it straight on. So it is probably the most common circular figure in everyday life, an ellipse. So I think you ought to know how to draw one. Artists use them all the time because they are drawing circular objects like that looked at an angle.
Right.
And they have a template to do it, sort of like a stencil.
Oh, okay.
But we'll make one from scratch. I'll use your circular figure that is a circular figure with one focus and make two foci. One there and one there.
Okay.
And I told you need a piece of string. Put it between the two foci. And the pen. You just put the pen right there next to the string and let the string do the work. Okay?
Okay.
There you go.
Oh, neat.
Isn't that neat?
Yeah.
There was one focus. There's the other focus. And here you have the figure that is called a what?
Ellipse.
Ellipse, yeah, E-L-L. And it's probably the most common circular figure around the house because every time you look at what you think is a circular figure, if you look at it from any kind of an angle, you're actually seeing an ellipse.